So yesterday we did graphing square roots, so in this case we're going to graph cube root functions this time. It's very similar to what we did yesterday, except instead of using the 0, 1, 4, 9, and 16, those numbers are going to be changed this time because it's the cube root. Our cube root functions look like this, so they look sort of like an S. With the square root functions, so with the square roots, we needed 3 points. With the cube roots, you need to determine 5 points. Now, on your worksheets and maybe even on the test, there might not be enough room for 5 points, but you need to at least show me your 5 points in your t-chart. Okay, so we want to graph this -3 and then the cube root of x. So now we're talking about the cube root. So now we need to pick numbers for x that we know the cube root of. And if you remember the graph from the previous slide, this time our graph is going to go on the negative side as well as the positive side for the x's, because I can take the cube root of negative numbers. So if I'm looking solely at the x here, the cube roots that I know how to take the cube roots are -8, -1, 0, 1, and 8. Any numbers in between I don't know how to take the cube root of unless I have a calculator, and we can't use calculators, so we got to pick numbers that we know the cube root of. And then we plug it in just like we did before. So we have -3, and the cube root of -8 is -2, so -3 times -2 is +6. And then again with -1, -3, and the cube root of -1 is -1, so -3 and -1 is +3. And then we plug in 0. The cube root of 0 is 0, -3 times 0 is 0. Then we plug in +1. -3 times the cube root of +1 is 1, so that gives us -3. And then the cube root of +8 is +2, so we get -6. Now we graph this thing. So we get -8, 1, 2, 3, 4, 5, 6, 7, 8. Mine goes off the graph, so 1, 2, 3, 4, 5, 6. So I'll do my best to estimate where it's going to be. And then -1, +3. And then 0, 0. And 1, -3. And 8, -6. So if I were to do it on a normal size graph, it looks something like this. And now we can change it. You know, we can make the x's go by 2's and the y's go by 2's, and it'll make it a little bit smaller and easier for us to fit on our graph, but it's not really necessary. As long as you have the 5 points over here, whatever you can fit on the graph is good enough for me. The last thing we have to talk about is the domain and range, remember, just like before. Now if you look at this graph is going to continue forever and ever in both directions, left and right, and in both directions, up and down, and it's never going to stop. Nothing is going to be undefined or anything like that. So with the domain for this one, it's all real numbers. And then if we look at the range, again, all real numbers. So anytime there's anything where there's nothing that's undefined or no place where we start and stop, then it's going to be all real numbers. So let's try this one. Now we have a 1/2. So again, we have nothing added or subtracted to the x underneath. So we're going to use that -8, -1, 0, 1, and 8. And we plug in the numbers, so we get 1/2 times, the cube root of -8 is -2, so 1/2 times -2 is -1. Then we have 1/2 times the cube root of -1, which is -1, so that's -1/2. Then we have the cube root of 0, so that's 0. And then we have +1, and then we have +8. And then we graph this thing. So we have -8, -1, it's down here, -1 and -1/2, 0, 0, 1 and 1/2, and then 8 and 1. So if we look at this one is a really, really, really skinny S. And even though it's really skinny in the little window that we have here, the domain and the range are still going to be all real numbers, because that thing is going to go on forever and ever, and eventually it'll reach infinity. Well, technically it doesn't reach infinity, but it goes until infinity, which never ends in both directions. It's just going to take longer to get there than the last graph. So we have all real numbers and all real numbers. Now please do not think that just because these numbers are the same numbers but opposite signs that they're all going to be that way, because we're going to see in a couple slides how that doesn't happen. So why don't you pause the video and try this one yourself. So our t-chart, again, -8, -1, 0, 1, and 8. We plug in the numbers, so we get 4 times -2, which is -8. And then we get 4 times -1, which is -4. And then 4 times 0, which is 0. 4 times 1 is 4. And 4 times 2 is 8. And then we graph this thing. So I get -8 and -8. 1, 2, 3, 4, 5, 6, 7, 8. All the way down there. And then I get -1, -4. And then 0, 0. And 4, 4. And then 8, 8. All the way up there somewhere. So it looks something like this. Remember, again, I could have made everything units of 2, and then it would have been a little bit smaller, a little bit easier to see, but it doesn't matter how we do it. And the domain, again, all real numbers. And the range is all real numbers. Okay, here's a problem now where x's are not going to be the -8, -1, 0, 1, and 8. But I do want them to be those numbers. So -8, -1, 0, 1, and 8. I want them to be those numbers. So in order for it to be -8 under the cube root, I need to figure out what x has to be in order to add 4 to it to get -8. And that's -12. Same thing with -1, x has to be -5. And then to get 0, x has to be -4. And then to be 1, x has to be 3, -3. And then to get 8, x has to be 4. And then we plug it in, so 3 times the cube root of -8 is -2, minus 1, and that's -7. If I plug in -5, I get -1 of the square root, and the square root of -1 is -1, so then I get -4. And then I do that same thing with 0, and then I get 1, -1. Then I plug in 3, I plug in -3, I get +1. So 3 times 1 is 3, minus 1 is 2. And then I do the same thing with +4. +4 is 8, the square root of 8 is 2, 6 minus 1 is 5. Okay, let's graph this now. I'm going to scooch it over a little bit over here. Like so. So I get -12, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 7. 1, 2, 3, 4, 5, 6, 7. And then -5, -4, -4, -1, -3, +2, and then +5. So a little something like that. And again, the domain is all reals, and the range is all reals. And the final one, you can pause the video if you'd like to try this one on your own. Again, I want it to be -8, -1, 0, 1, and 8. So when I plug in -8, when I need to get -8 for x minus 4, x has to be -4. And then if I want it to be -1, x has to be 3. If I want it to be 0, x needs to be 4. If I want it to be 1, x has to be 5. And if I want it to be, 8, that has to be 12. And then if I plug it in, I get 2 times -2, which is -4. Then I get 2 times -1, which is -2. And then I get 2 times 0, which is 0. 2 times 1 is 2. And then 2 times 2 is +4. And then I graph this thing. Let's see, mainly positives, but centered. So -4, -4, and then +3, and then -2, 4, 0, 5, 2, and then 12, 4 is going to be somewhere up here. So like that. And again, all reals, for the domain, and range is all reals again. Now here's your homework for the second day, which is the other 6 problems for the page before. And make sure that you come and see me if you have any questions. You'll have a test next week, Thursday or Friday of this following week.